All right, so that was Key Sizzle just said hi to third period. All right, so okay, everyone get out of your system. All right, here we go. So one of the things you have to definitely be able to do on the exam, the FRQ or the multiple choice, is gravimetrical analysis. Remember when we took the calcium out of water? Remember the good old days? Hard water lab, right? So the first thing you do is when it talks about precipitating out, you write out a net ionic equation. Well, you got Ag and you got Br, so I'm going to do this. I'm going to go Ag plus Br minus. I'm going to arrow AgBr. It's a solid. Because whenever I do gravimetrical analysis, I want to use the net ionic reaction. So then what I'm going to do is I need moles. Because remember, it's solution stoichiometry, so normally they're going to give you molarity in liters for all these, right? Or they'll give it to you in milliliters. In this case, they actually made it easier since it's multiple choice. They gave you the moles. So they did the M and L for you already. But one thing we always have to pay attention to with solutions is you got to pay attention to the subscript. So watch. It says that 0.1 mole of NaBr, the subscript there is 1. So that's going to give me 0.1 moles total of Br minus. There. Then it says I have 0.2 of BaBr2. Well, when BaBr2 breaks into solution, you get Ba2 plus and what? 2Br minus. You get double that, right? So what I'm going to do is I actually have to double the molarity, so I'm going to double that to 0.4 moles of Br minus. So the total amount of Br minus floating around in there is 0.50 moles. I have to pay attention with the subscript. I have to pay attention to the number of ions. Then it asks me, what is the minimum number of moles I have to do to get rid of the Br minus in solution, precipitate it all out? Well, the ratio is a 1-to-1 ratio. So if I have 0.5 moles of Br, how many moles of silver do I have to add into that sucker? I have to add in 0.5. That will then, my change line is going to be minus 0.5, minus 0.50, 0, 0, and then on the other side, I would produce 0.5 moles of AgBr. If I wanted to know the mass of the precipitate, all I would do is multiply the moles times the molar mass. And that's how you do a precipitate, a gravimetrical analysis if you're using solubility rules to knock the ions out. All right, next one. Beaker contains, here, let me set this up here. I'll show you this one. Again, contains what's the final concentration of sulfate ions. It contains Ba, if you think about it like this, it contains barium nitrate, right? You have barium nitrate and sodium sulfate. Remember, it's a double replace reaction. Sodium and nitrate are going to go together, and Ba and SO4 are going to go together. Those are spectator ions, so those don't matter. So my net ionic equation is Ba2 plus SO4 2 minus is equal to Ba SO4 as a solid, right? So that's the first thing I do is I write out my net ionic reaction. Just look and check. If you see a solution and a solution being mixed, it's going to be a precipitate reaction, unless it's an acid base, but you'll be able to spot that. Next thing I need to do is I need to find moles. I do molarity. So I'm going to do this. If you notice there, it contains NaSO4. So I'm going to do that times subscript. So if you look, I'm going to go 0.50 milliliters, 0.050 liters times 0.2 molarity. How many moles am I going to get? And the subscript for SO4 in that case is 1. So I'm going to do that times that. Let's say you have trouble doing that math in your head. This is where scientific notation comes in. I could go 5.0 times 10 to the negative second, and then I could go 2.0 times 10 to the negative first. And then I do this. 5 times 2 is 10. Add the negative exponents, 10 to the negative third, right? When I go to take it out, I go pop over. I'm going to get 0.010 moles. So if you have trouble doing it mental math style, it's designed to be done in scientific notation. Put both of them in scientific notation and just multiply across. I get that. The next one I have to do is barium. I need to know how many moles of barium. Well, it says in the problem I have 50 milliliters of a 0.1 molar solution, so it's 0.050 liters times 0.1 molarity, and the subscript is 1. So I'm going to end up with 0.0050 moles. If you do it in scientific notation. If you have trouble, it'll be easier. Who's my limiting reactant? Which one's going to be my limiting reactant? Which one's smaller? Barium. So I'm going to basically take this, so it's going to be minus 0.0050, minus 0.0050. this is going to be 0, this is going to be 0.0050 moles. They're asking me what's the final concentration. In chem, that means molarity. So I 0.005 moles, I'm dividing by 0.1 liters. Whenever you divide by 0.1, it's basically going to kick the decimal over one place to the right. So whenever I divide by 0.1, the decimal is always going to go there. I'm going to end up with 0.505, but bam! That is my concentration of sulfate left over. If I want to know how many moles of barium sulfate were produced, it's going to be plus 0.0050. That would be my moles. If they ask me grams, that would be in a free response problem. I would just multiply times the molar mass. But in order to do gravimetric analysis, you have to get into moles. M times L times subscript. You have to pay attention to because they do get a little tricky. Next one. They're asking concentration, right? This is going to be good to remember a couple things. You have to remember subscript stuff. 46 grams of MgBr, 184. Whenever I want moles, grams over molar mass, quick stack, I get, well, moles. So I'm going to go 46 over 184. Sure looks like 50 over 200 to me, because remember, we can ballpark the crap out of these. So 46 divided by 184, I'm going to say 0.25, right? Moles. Except, what do you notice about Br in that equation? Br2, which means if I take MgBr2 and dissolve it, I'm going to get Mg2 plus 2Br minus, right? So I double it. So remember, that's where we talk about molarity times liters times subscript. Whenever they talk about ions, subscript matters. So M times L times subscript. So really, I have 0.50 moles of Br minus, and they want to put it in 0.5 liters of solution. So my molarity of Br, moles over liters is molarity. I do 0.5 moles of Br minus over 0.5 liters, and my molarity comes out to be over. All right, next one. They're asking molar solution to Cl minus. Oh, wait a second. Oh, M times L times subscript. Watch what I do. First one is 300 milliliters of 0.60 NaCl. So I care about the Cl there. Subscript is 1. So I'm going to go 0.6 is my molarity. My liters is 0.3. My subscript is 0.1. 0.6 times 0.3 is going to give me 1.8 moles of Cl minus. Then I'm also combining it with 200 milliliters, 0.4 MgCl2. So I'm going to go 0.4 is my molarity, 0.2 is my liters, but look, gangster Cl, there's double. So guess what I have to do? Multiply by 2. So I'm going to go 0.4 times 0.2 times 2. I'm going to end up with 0.16 moles of Cl minus. They're asking me the concentration, which is the same thing as moles over liters. Well, if I add these two together, I get 0.34 moles of Cl. So I'm going to go 0.34 moles of Cl minus. Now, my new volume. If I take, I'm adding 200 and 300, so I divide by 0.500 liters. Anytime you divide by 0.5, it's the same thing as multiplying the top by 2. Anytime you, remember this on the AP exam, anytime you divide by 0.1, you just move the decimal 1 to the right. Anytime you divide by 0.5, just take the top number and double it. That's all you're doing. It's quick solving. So in this case, I'm dividing by 0.5, so whatever's on the top, I just double it. What's 0.34 times plus 0.34? Bam! 0.68. Boom shakalaka. That's how you do it. It helps for some quick solve stuff. The key thing for this one is you gotta remember subscripts. So you gotta remember the subscripts. M times L times subscript anytime they talk about ions. So I didn't give you this question. I meant to give it to you, but I messed up. Copper chloride, least soluble. When we talk about solubility, if you take CuCl2, it's going to break into Cu2 plus and 2Cl minus, right? That's what you're going to get. This is an example of Le Chat. The greater the common ion, if you add this direction here or here, it's going to cause it to shift this direction. So pay attention to the number of ions. So if I look here, it says copper chloride will be least soluble in which of the 0.02 molar compounds. Well, I have Cl there. That would add 0.2 Cl there, which would Le Chat it this way, which would go that way. That has copper, which is adding 0.2, which would look at it that way as well. That little gangster has double Cl, so it's actually going to add 0.04 to it, which is really going to look at it, because the more I add, the more away I get. So when they ask you about solubility with common ions, this works for acids, this works for everything. The greater the concentration on the right means you're going to decrease the solubility or decrease the ionization. If you're talking about acids, so when they talk about least soluble in which of the compounds, you're looking to see if it's polar or non-polar. So sometimes you'll just have, remember, like dissolves like. So least soluble, if you have a polar compound in something that's non-polar, that wouldn't be soluble. But these are saying molar solutions, so they're all aqueous, so they're all in water, so that doesn't matter. So what matters is it's a common ion problem. Just be aware of that. Next one. If you look right here, how many moles of NaSO4 must be added to 500 milliliters of water to create a solution that has a 2 molar concentration of the Na plus ion, right? So we want to create a 2 molar solution, right? So if we look, the molarity is 2 molar right here, right? So 2 molars. How many liters they want? 0.5 liter X. I just need to know how many moles of Na plus I need. Okay. So if I multiply liters times that, I get what? Moles. I get 1 mole. I just need 1 mole of Na plus. Right? 1 mole of that equals 2. But remember, Na2SO4, oh wait, breaks up into 2 Na plus and SO4 2 minus. So if I only need 1 mole of this, how many moles of this would I actually require? How many moles of Na2SO4 would I require? It would be 0.5. Hey, or you could do it in a grid. You could do this. You say 1 mole of Na plus. Well, what do you know? You know that there are 2 moles of Na plus in 1 mole of Na2SO4. So you could do it that way if you want. And ultimately cancel out, and then that would tell you, because when you dissolve, because they're asking you how many moles of NaSO4, if you want to do that in a grid, you could do it that way. You have to pay attention to the ion ratios. Next. Don't need to know that. This one, I hate this question, and they put it on the exam. This is ratchet. This is a ratchet question right here. But they love to do this on the AP exam, and it annoys me to no end. I think it's dirty. Look, how many liters of water must be added? Be aware they ask this a lot. They snicker when they do it. They're like this. Because they think it's funny. I don't think it's funny because it's like a trick question. What they'll do is you have 4 liters of a 6 molar solution. So that's my stock. So this represents stock solution. It's M1V1 is equal to M2V2. Anytime we do a dilution, you take the molarity of the concentrated solution times the volume equals the molarity of the diluted solution times the volume of that. Well, you have 4 liters, so that's your volume of your stock, 6 molar, and then you want to make a 2 molar solution. So you go and solve for it. You're like, oh, 6 times 4 is equal to 24. Sweet. 24 divided by 2. I got this 12. Happy face. Oh, wait a second. Sad face. Ding, 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 ding. Why? Because College Board is dirty. That's why. Because look, they ask you how much has to be added. If you start with 4 liters, your total volume you need at the end is 12 liters. So you have to take V2 minus V1. I know it's dirty, but they do it. So I have to warn you about it, because otherwise it would be sad. I don't want this face. So then you just go V1 minus V2 minus V1. So we know it's 12. 12 minus the original 4. So you just have to add 8 liters of solution. Not a big fan of that question. On the AP review quiz I gave you, the last one you take, there's one on there. The reason I put it on there, not because I enjoy the problem, is because I have to prep you for the exam. I don't think this tests your chemistry knowledge. This is like a trick question. I don't like it. No me gusta. That's Spanish for I don't like it. No me gusta. All right. KSP. KSP also comes under the idea of solutions. So when we talk about KSP, remember this. Means solubility product means we do this when we write a KSP expression. We go Ag Cl is a solid. It's going to break into Ag plus Cl minus, right? So I get Ag plus Cl minus. When I go to do this, I always do a MICE table or mini ice table because solids aren't included in equilibrium expressions. So I'm going to go plus S, S, and S. And we always do our expressions separately so we don't get confused. Ag plus and Cl minus is going to be equal to our KSP value. And all I do is go from the E line and I drop it into the expression, drop it in the expression. Now when I do that, I get S times S, which is the same thing as saying S squared is equal to KSP. So if my KSP is 1.8 times 10 to the negative 10th, all I have to do is take the square root of it and I will get S. That's why E is the correct answer. Remember, when you go to set up a KSP equation, we have to do a mini ice table. You do your E line, you drop from your E line into the KSP line. Don't get confused. Okay? Next one. Here's an example of getting confused or not being thorough. It says solubility of strontium fluoride. So when I go look at strontium fluoride, I use my periodic table. Strontium's 2 plus, fluoride's minus 1, so it would be SrF2, solid on the left, is going to break into SR2 plus 2F minus. I go to do a ice table. I'm going to get plus S and plus 2S. So this is S and 2S. They tell me, I'm going to write my equilibrium expression down here, KSP is equal to the concentration of SR2 plus to the first, F minus to the second. I do them separately so I don't get confused. I'm going to take a different pen, and they tell me the solubility. That's S. The solubility of SR and F minus are not the same. It is a 1-to-2 ratio. So S is really only here, 1.0 times 10 to the negative third. What do I have to do to get my fluorine? I have to double it. So that double would be 2 times 10 to the negative third. So I do my E-line work, then I drop into my expression. Bam and bam. So when I drop into my expression, I'm going to get 1 not 1.0. 1 times 10 to the negative third times 2 times 10 to the negative third squared. So watch. When I square a number in scientific notation, this 2 squared is going to be 4. This I just add, basically I'm multiplying, so I'm going to basically negative 3 plus the negative 3 is going to be 4.0 times 10 to the negative 6, or 4 times 10 to the negative 6, times 1, it's not 1.0, 1 times 10 to the negative third. Then I'm going to just do this. When I multiply, 1 times 4 is going to be 4. Negative 3 plus a negative 6 is going to be 4 times 10 to the negative 9th would be my KSP value. So you can use scientific notation. It will be very friendly. You can use scientific notation to solve that problem on the AP exam. Next, solubility of BAF2. If you think about BAF2, this is just, remember there's shortcuts. Remember, if it's only 2 ions, it's S squared is 2 ions. 3 ions is going to be 4s cubed. 4 ions is going to be 27s to the fourth. You still have to, either way, you still have to, if it's an FRQ, because at FRQ they'll make it a long, drawn-out problem. You would still show your MICE table and do all that. But this case, if you know it's 3 ions, you know KSP is just going to be equal to S, remember, is solubility. S, when we're solving for S, is the solubility of each ion. And that's where you have to look on the, I line or the E line, like here. S, when we find S, or S is given in this one, it's the solubility of SR2 plus. The S is not equal to the solubility of F minus because it's double. You get double the amount. So when you find S, you're finding the molarity of the ion in solution. That's what we're finding. So then here, the shortcut-wise, you know, if you look here, you know that it breaks into 3 ions because it goes S and then 2S. That's how you know 4S. They use X, it's the same thing. You can use either one. It's the same idea. All right, 26. Silver hydroxide would be the least soluble in a solution with a pH of what? So when we're talking about KSP and solubility product, common ion again. The greater amount of an ion you have on the side, you'll drive it this way and reduce the solubility. Well, in this case, pH is related to OH concentration, be OH minus, because as pH increases, we know OH minus concentration increases as well. So you're going to get the greatest amount on the shaft you get the greatest amount of Lachette if you have a pH of 11. So only when you have compounds that have OH minus there, it affects solubility. So it does the compound, and the pH will drive it. Don't give you pH because you're going to drive it back this direction, reducing the solubility of it. Because they're asking you, when is it the least soluble? So that's basically what it's referring to. Next. Don't need that. Don't need that anymore. Don't need that anymore. Okay, this is the last one I think I assigned. If I look here, it says, hey, you have a substance that's 5 molar solution. So if I look, the molarity is 0.5. I'm going to put it in the equation. Moles is on top, liters is on the bottom. It says I have 4 liters of it. So I have 4 liters of the solution. Right? Moles. They're asking me, what would the possible molar mass of the substance be? Well, first I need to get moles because I know this. Grams divided by molar mass is how we quick solve for moles, right? If I wanted to switch it, I could switch these two. Molar mass is grams divided by moles. It's the same idea in the overall equation. So what I'm going to do is I'm going to take 4 liters times molarity. So what's half of 4? It means I have 2 moles on top. And then if I have 240 grams of the substance is equal to 2 moles. My molar mass has to be 120 grams. That's how I figured that out. Because it goes back to the idea of molarity. Molarity is moles over liters is equal to M. They give me M, they give me L, which means if I multiply these two, I get moles. Then I know grams over moles is always equal to molar mass. When we've been quick solving without a calculator, we always say grams over molar mass is an easy way to find moles. They're related to each other. You just need to flip them however you need to flip them to find the correct number of moles.